Okay, so we're playing around with electric fields. Here's our expression for the electric field produced by a particle of charge q, or in this case, let's make it q naught. Okay, it looks like that. And let's put this charged particle at some location in the xy plane such that it lends itself to some intuition. So here's x and here's y, and let's put it, this is x equals minus 1, minus 2, let's say right here. Let's put it at x equals minus 2, y equals 0. So there's the particle of charge q naught. And we know from the last lecture that the electric field produced by this particle in the xy plane looks like this. Some constant times the value of the charge times the variable x minus x naught, which is minus 2, so that makes it x plus 2 I hat, plus y minus y naught, but y naught is 0, right? Y naught is the y coordinate of the location of the charged particle. So we have y minus 0, j hat, all of that over x plus 2 squared plus y squared to the 3 halves. Okay, so now we want to show what the electric field reduces to at some specific location. So let's say we want the electric field right here at the origin. Now we know that electric fields diverge radially away from charged particles. So if in red we draw electric fields, the electric field has to diverge radially away. So an arrow there would look like that. Over here it would look like that. Try to make these arrows about the same length. There it would look like that. Over here it would look like that. And so on. And if we move further away, the arrows should get smaller. Let's just draw a few of them like that. And at this location it needs to be pointing to the right. So from that we can figure out that the electric field at the origin must have, so the electric field at x equals 0, y equals 0, must look like this. K times q naught over r squared, but the distance from here to here is 2, so we square that, that gives us a 4. And then there's a unit vector, and that unit vector needs to be pointing to the right, so that's an I hat. Okay, so that it's easy to see that, to see how to go from this to its expression in the xy plane for this location. It's a little bit trickier for other locations. We want the general expression to be able to find it at any location, but let's just check that this expression reduces to this expression for x equals 0, y equals 0. So this becomes E00, right, that is K q naught times square brackets. Now x is 0, so we have 0 plus 2, which is just 2 I hat, plus y is equal to 0, so 0 times j hat is just 0, so there's nothing else there, divided by 0 plus 2, which is 2, squared, plus 0 squared gives us 0, and so we have nothing else in there except the 3 halves remaining on the outside. Okay, so what does that look like? Well, it's K q naught times 2 I hat in the numerator over 2 squared to the 3 halves, which is the same thing as 2 cubed. Right, so that gives us K q naught I hat over 4. because it's just 2 squared. And so the two expressions match.